You know that feeling, right? When a number just doesn't seem to add up or a story someone tells you keeps shifting. Well, what's behind that feeling of inconsistency? Today, we're going to pull back the curtain on the science of reliability, a really important concept that, believe it or not, you already use every single day. Let's dive in. So let's start with something we can all relate to. You step onto your bathroom scale, you're just looking for one clear number. But what happens if the scale, well, what if it can't make up its mind? You see what I mean? You step on, it says 160.2. Okay. You step off, step back on a second later, suddenly it's 158.9. You try it a third time for good measure. Whoa, now you're at 161.5. It's not just frustrating, it's a perfect real-world example of an unreliable measurement. The tool just isn't giving you a consistent answer. And it's not just about bathroom skills, of course. As the psychologist Hugh Killican puts it, we expect this kind of consistency from pretty much all our tools. I mean, think about it. A speedometer that bounces around while you're driving at a steady speed? That's not just useless, it's actually dangerous. We instinctively and rightly demand reliability. So this fundamental need for consistency, what do scientists and researchers actually call it? Well, they call it reliability. And it is the absolute bedrock of any trustworthy measurement, whether you're working in a high-tech lab or just, checking your weight in the morning. To put it as simply as possible, reliability is all about consistency. If nothing has actually changed, a reliable measure should give you the exact same result time after time after time. A reliable scale shows the same weight. A reliable speedometer shows the same speed. But there's a little more to it than just that. Okay, so let's break down the first major type of reliability. This one is all about consistency over time. Researchers have a name for it. They call it external reliability. And the big question it asks is this: is this measurement stable from one moment to the next? Think of it like this. Let's say you're a witness to an event and you give a statement to the police. If they ask you to tell them the story again a week later and your story completely changes, well, your statement is going to be seen as pretty unreliable, right? It just doesn't have stability over time. And that, right there, is exactly what external reliability is. It's all about measuring how stable the results are when you repeat the test or the measurement on a completely different occasion. So how do you check for this? Well, researchers have a pretty straightforward way. It's called the test-retest method. It's exactly what it sounds like. You give a group a test, you let some time pass, then you give that same group the exact same test again. If the scores are pretty similar both times, bingo, the test has high external reliability. Pretty simple, right? Okay, so that's consistency over time. But what about consistency inside of a single test, at one single moment? This brings us to the second type, internal reliability. Now, this isn't about stability from week to week. It's about whether all the individual parts of a measure are playing on the same team. Let's go back to that police statement for a second. This time, imagine you're not changing your story a week later. Instead, you're contradicting yourself in the very same conversation. One minute, you're saying the getaway car was blue. The next minute, you say it was green. See the problem? Your story isn't internally consistent. And that's the core idea of internal reliability. For a test to be internally reliable, like, say, a questionnaire that's supposed to measure anxiety, all the questions on it should be pulling in the same direction. They should all be getting at that same core idea of anxiety. A really common way to check for this is called the split-half method. Researchers basically take one test, they split it down the middle. A popular way is to compare the odd-numbered questions to the even-numbered ones. And then they check if the scores for each half are consistent with each other. If they are, then the test is considered internally reliable. Okay, so a measurement can be consistent over time and consistent with itself. So that means it's a good measurement, right? Problem solved? Well, hang on, not so fast. This is where things get really interesting, because we have to talk about the crucial difference between reliability and another concept called validity. So here's the key takeaway. Reliability is about consistency. Validity is about accuracy. Let me give you an example. Imagine your scale told you that you weigh exactly 10 pounds every single day without fail. That scale would be incredibly reliable, but it would also be incredibly wrong. It's not accurate, so it's not valid. The classic Target analogy explains this perfectly. Take a look at this. All the shots are bunched up together really tightly. That shows consistency, right? That's reliability. But they're all way off in the corner, nowhere near the bullseye. That means the measurement isn't accurate. It's reliable, but not valid.
Now this is what we're aiming for.
See how the shots are all clustered tight together? That's our reliability. And they're centered right on the bullseye. That's accuracy, which means our measurement is also valid. This is the gold standard for any good measurement. You need both. So we've defined reliability, we've talked about the different types, and we've separated it from validity. But let's get down to it. Why does any of this actually matter to you, in your day-to-day life? Well, for starters, reliability is the absolute backbone of good science. It's what allows other researchers to replicate findings to see if they get the same result. It's the foundation for all those psychological tests we trust. Honestly, without it, research findings are basically just noise. But it also gives you a really powerful tool, your own personal crap detection system, to borrow a truly fantastic phrase. Because when you understand reliability, you get so much better at questioning the world around you. You start to see the shaky claims and the flimsy evidence in news reports, in advertisements, everywhere. So we're going to leave you with this question to think about. Now that you know what to look for, the signs of consistency, of stability, start applying it. How reliable are the studies you read about, the headlines you skim, the facts that people share online? Understanding reliability doesn't just make you smarter about science. It makes you a more critical thinker in every single part of your life.